sí, está funcionando. Bueno, vale.
Hello.
Maybe we'll wait. It's still 5 minutes off.
Hello everyone, welcome back. I'm excited to introduce our next speaker, Joao Provenza. He will be speaking about the decoding synthetic monitoring, a journey from E2E UI test to service level probots. Stage is all yours, Joao.
Thank you. Still some people coming in. Welcome everyone. I know that we just came from lunch and we had a few drinks. Just to get a feeling, how many fingers can you count right now? No. It's fine. Okay. Just allowing everyone to sit down. Welcome. My name is João Provenza. This is my talk, Decoding Synthetic Monitoring, a journey from end-to-end UI tests to service level probes. I'm going to explain what I mean by this. I am a quality engineer at a company called Ada Health, and I come from Lisbon, Portugal, right on the other side of the peninsula. This is my blue sky tag if you want to follow me or something like that, or just send comments to me. And so the idea for this talk, well, the story that I want to tell you started a few years ago. At the company where I was working, we had an on-call team that essentially, they monitored our product 24/7. This was a team of engineers that are in rotation, and we have monitoring tools in place. We use a lot of honeycomb with alerts, and at any given moment, those tools may detect that something is wrong with our product, and they will bring up an alert for our on-call team who gets woken in the middle of the night. However, we had this issue where essentially, those monitoring tools, they require traffic to be present in order to detect that something is wrong. And because of the nature of the architecture of our, microservice architecture that we have a few pieces of it that are kind of like dedicated to specific clients. And those clients have their own users, and traffic is a bit, it shifts throughout the day. So imagine a product that people will use throughout the day most of the times, but when it comes at night or maybe on weekends, you see little to no traffic, and then that's highly problematic for our on-call team because essentially we don't know if the product is working or not because we depend on the traffic existing and events being fired up so that we can get alerts in case the tools detect that there's an error or if things are taking too long to respond or stuff like that. And back then, someone had this idea of, okay, if we have this problem of periods of time where we have no traffic, there's also all of these quality engineers here who are working on test automation and using Selenium and other technologies to build end-to-end UI tests. Why not repurpose those tests and run them periodically every half hour to generate traffic that simulates what a user is doing? And so in these off hours, like in the middle of the weekend or during the middle of the night, they're kind of giving us that pulse, that little bit of traffic that will tell us if the basic use cases are being successful or not. And that's what we did. A few years ago, we started using the same automated tests that we had for testing the product whenever we changed it, for monitoring. We started running them every half hour against production so that we would get a better pulse to how things were faring. This proved to be such a useful approach to us that the automated tests not only generated the traffic and then we looked at the backend data to understand if something was wrong, but even if the tests themselves failed, that was basically demonstrating that in production something could be going on and they would alert directly an on-call person, hey, I just failed, so you should check if everything's working because this may be an actual problem, just the fact that I wasn't able to complete a complete use case. Of course that in this situation, you can imagine what becomes a highly critical thing when you have these tests running every half hour in production and producing alerts to a specific team. Flaky tests, right? And here it was really important, and don't get me wrong, I've worked with Selenium and these kinds of technologies for a long time. I think I started working with Selenium back in 2007. And we actually have a pretty stable set of end-to-end UI tests. I'm pretty proud of the way the tests are set up. But the thing is, just a little bit of flakiness, and I always believe that with UI testing, flakiness can come from different places. We've had situations where someone just upgrades the version that we're using for some framework, and all of a sudden there's a specific part of the use case that becomes more flaky, and then we need to reanalyze and re-implement in a different way that lowers flakiness. Though we keep stability really well, there's always a little bit of flakiness, and usually low flakiness will be completely acceptable for testing purposes that you do a few times during a working day because you're testing things when specific events happen, when you're changing the product, when you're applying a configuration or something like that. But in a monitoring setup, even just 1% of flakiness, 1% of, let's say, false positives will be guaranteed to give you problems because it's going to wake people up in the middle of the night within the week because of the amount of times that we run these tests in production. So, at one point, we decided, we had the on-call team, they were doing a very good job in terms of understanding and reacting to problems happening in production, but their lives were miserable because they were being woken a bunch of times when they shouldn't. And so we decided it's time to find an alternative. And so I started looking into this topic of, okay, I'm using automated tests to exercise production every half hour. What exactly is this? And I found out throughout my research that this has a name. It's called synthetic monitoring. Looking at what exactly synthetic monitoring is, I found out one of the definitions is simulating user interactions to assess how the system behaves in production, which was exactly what we were doing. We have automated tests that are generating traffic, and at the same time they are asserting if a user can conduct in a happy pathway a complete core use case. It's what we call let's say, a type of active monitoring, whereas when we usually talk about monitoring as a whole, we think about passive monitoring, where you just look at what's happening that's coming from the world, what the users are doing, and how it's impacting your system. Instead of doing that, with active monitoring, you're actually introducing the events within your system so that you can look how it reacts and hopefully understand if problems are about quicker and in a more effective way. Another definition that I found was automated scripts that mimic predefined user paths to evaluate availability, meaning is the system up or down? Can you complete a use case or not? Functionality, transaction success, can you actually go through the whole use case? Can a user actually take their shopping cart and go to the end and pay for it? And also for performance, response times and latency. For us, it was more about the first two, but I will get more into that later on. Okay, once I understood that there was this whole discipline called synthetic monitoring, which was actually what we were doing, I started trying to understand what alternatives I may have, what were the leading practices and whatnot. What I found is that when you search for this, at least it's been my experience, when you search for this term online, you're going to find a lot of contents coming from vendors. You know, monitoring tools that will explain what synthetic monitoring is, and they will explain how their products can help you to conduct it. But I didn't find a lot of stuff about, you know, the craft of synthetic monitoring and when should you use it, when shouldn't you use it. Eventually, I found some pieces that I put together and formed my own understanding. And for me, reasons why we should use synthetic monitoring, and also hinting at reasons, maybe a justification that maybe you don't need to use synthetic monitoring, which I think it's important to understand. First, if you have low traffic or highly fluctuating traffic, which was, as I explained, our situation, we had a product that sees a fair amount of traffic throughout the working day, but at the end of the day, usually there's not a lot of users accessing it, just because of the nature of the business. When you have distributed systems with hard to trace end-to-end journeys, meaning that you see a lot of stuff in your monitoring, you understand that a service is behaving in a certain way, but it's hard to pinpoint exactly how that translates into a user journey that is happening with, through your system. If you have an automated script that's basically mimicking what a user is doing, it's much easier for you to correlate from start to finish all of the events that are involved in that. And finally, something also that I found was like when you have ambitious service level agreements in combination with the others. So for those of you who don't know what a service level agreement or an SLA is, it's basically a contract that you agree upon with your clients where you say, these are the levels of service that we're going to have. Usually it includes an uptime metric, like we assure 99.95% of availability, meaning that only in 0.05% of the time during a month, the system can be down for some reason. Why is this important when we're talking about synthetic monitoring? In combination with the fluctuating traffic, imagine that on a Sunday, you have a user that accesses the system at 1 a.m. and everything's fine. He's able to do whatever he needs to do within the system. Then at 1 p.m., you have another user that accesses it, like little to no traffic, and they bump into an error. You're going to need to assume that your downtime was actually 12 hours because you have no way of understanding what happened between 1 a.m. and 1 p.m. And that's one of the ways in which synthetic monitoring is really useful for us because it gives us that pulse that increases the granularity and it tells us, well, actually the system started bumping into a problem at 12 p.m. It wasn't at 2 a.m. or something like that, which would be disastrous from a time span perspective. But of course, if you look at these, this also hints into situations where maybe synthetic monitoring is not the thing that's right for you. If I imagine a system like, I don't know, Netflix, that's at any given point in time, there's always someone somewhere watching a TV show on Netflix. They get a huge amount of traffic. Maybe synthetic monitoring doesn't make as much sense for them. So just take that into mind. Okay. I was already understanding that, yes, synthetic monitoring, we're definitely doing something that makes sense within our context. I understand what it's all about, but how are people doing this differently throughout the world? What can we find out there? How can I approach this other than the UI automation approach? And actually what I've found from people discussing the topic is that a lot of people went through the same story as we did. They had UI tests laying around, a lot of them built with Selenium, and they just decided to repurpose those to generate traffic in production. But for me, this approach has had a problem in my mind, which I'm trying to express here in this visual, which is, for me, when you're doing synthetic monitoring, there is a specific part of the system that we run, and we want to target with this kind of monitoring. However, the way we were doing that, there's also going to be another big chunk of the system that is not actually run by us, and we're not targeting with synthetic monitoring, and that's where the problems are coming from. Let me explain. What is the thing that I actually want to monitor for here with my synthetic monitoring? It's basically what I can run. It's whatever's running in our data centers, or in our case, in our cloud providers, where we have services, we have databases, we have infrastructure, and then there's like this back-end API that is serving the front end, which in our cases means either a web application, a website, or a mobile application. The front end, but that comes with its own baggage, right? It's a lot of JavaScript code running in those things, or it's mobile apps that react in their own ways. I'm not telling you that you don't want to monitor for, you know, that part of the story, but you're not going to do synthetic monitoring on that. Usually things that go wrong here, like the problems that you want to solve, is stuff like, is there someone somewhere in the world running this obscure version of the browser? Or maybe there's an obscure Android device in which our app misbehaves or something like that. For that kind of monitoring, there's other tools that you can use, tools like Sentry that essentially detect stuff happening at the local level and then just call home sending data to Sentry so that we know that there are logs about stuff that we never imagined may be happening. But with synthetic monitoring, essentially, you are, building a framework, building automated scripts or tests with Selenium or other technologies like Playwright and Cypress. I promise this is the only slide where you will see these logos in. And essentially, you have these technologies handling the whole front-end part just to generate the traffic that we want to monitor at the entrance of our APIs that then go into the services that we have. But when you're doing this, this is actually simulating something that in real life we're not running. We're not going to bump into obscure device problems here because we're always running the same mobile app or we're always running the same browser with the same version. So, this is a moment where I think we should just pause and I should make this disclaimer. You're probably wondering right now, João, did you actually come to SeleniumConf to tell us not to use Selenium for something? Well, bear with me. I am in no way saying that you shouldn't do UI automated testing. I'm actually a fan of it, and I own a UI automation set at my company, but the way we strategize around that is that we thought that within our context, it made sense to run those very valuable end-to-end UI tests for testing whenever we change the product, and we still rely on them highly, and they produce a lot of value for us. And even if you don't think that in between the divide of testing and monitoring, maybe using UI testing for doing synthetic monitoring in your context is something that works for you. That's fine. For us, it wasn't, and so I wanted to find a different alternative and share that alternative with you folks. So I hope that this is fair enough for everyone, okay? Okay, so how can we do this differently? And the idea for the thing that we put in place came from one day I was talking to the head of SRE at my company. SRE, Site Reliability Engineering, people that know their observability, they know monitoring tools, they know how these things usually are done. And I asked, hey dude, how would you do this if you lived in a perfect world? And what he did is that he explained, well, usually where I come from, these things are done using something called Prometheus probes, okay? Prometheus is a monitoring tool. Even though they are called Prometheus probes, it's not exactly something that's proprietary of Prometheus. It's more like a standard, okay? It came from the Prometheus world, but actually you can use Prometheus probes or Prometheus-like probes with other tools. We're not even clients of Prometheus. We actually use Honeycomb and OpenTelemetry, and we achieve the same effects. But bear with me, I will try to explain what exactly this setup does. So if you imagine that you have a monitoring tool like Prometheus that's collecting data from production, and you're monitoring that data and producing alerts and observing it and exploring whenever you have to troubleshoot something, you also have a mechanism that allows you to call a probe every X minutes, and it's bundled in. And what it does is that it's going to use a language called the multi-target exporter pattern. We don't need to go deeply into details of what that is. Just imagine it's a standardized language for probes to communicate with systems. And it's going to call it a probe, and Prometheus offers you, out of the box as an open source project, the most basic probe that you may have, which is called the black box exporter. And what it does is that Prometheus is like, hey, black box exporter, please go check if that website in blue here is up or not. And what this thing does, okay, if it's telling me to probe this website, I already know that I need to do this HTTP request to it and expect a 200, a OK status code to come back. Maybe I can also, check some things within the response that I get, if I get a specific payload or not, but that's pretty much it. It's a very simple thing that essentially, whenever you tell him, hey, please probe that thing over there, it will reply with information regarding success and performance back to Prometheus so that then it can collect that data and, not only get the traffic that's being generated within the website itself, but also get the results from the probe itself. And as I was saying, we don't use Prometheus for this. We actually use Honeycomb, which is a different monitoring tool. It's a competing monitoring tool that we prefer. And we use something called an OpenTelemetry collector. I'm not going to go deep into that as well, but OpenTelemetry is just a standard that people within the monitoring world use to build these things, where you basically can interswitch different vendors, as I'm demonstrating here. Okay? And the OpenTelemetry collector does that function of, I'm going to call that probe every X minutes so that I can collect information from my website or my endpoint or whatever I want to probe. Okay? And so what my friend and colleague was telling me is that what I would do is that instead of having a very dumb probe that is only able of doing an HTTP request and get a response back, I would create something that's much more bespoke to our use case, and essentially doesn't do one request to the backend, but does a sequence of requests that will totally simulate what the UI is actually doing, what the front end is actually doing. So in his mind, he would replace all of that layer that we have with the front end actually running and a UI automation test set exercising the UI with a bespoke Prometheus probe that would simulate exactly what are the requests that we want to do to the backend. Okay? And this brings us a number of advantages that I will explain a little bit later. Once he explained this to me, I had a problem in hands, because I needed to set up a framework for different teams within my company to be able to produce these bespoke Prometheus probes. And I have different teams that have different contexts within the company, and they deal with different technologies. Some teams are more attuned to the backend. They work in Kotlin, and they deal a lot with MongoDB. Others are more like front-end attuned, and they do a lot of JavaScripting and TypeScripting and all of those technologies. The problem is that if I build a framework attuned to the backend, Kotlin and whatnot, the front-end folks, they will have a steep learning curve. The alternative is me having to maintain two different frameworks for the same effect, and that's not going to go well. But I started thinking, what would be ideal in terms of having everyone producing these Prometheus probes? And I noticed something that was kind of like pervading and common within the whole organization, and I could see it in almost all teams. Almost all of the teams were already using API testing tools, okay? So, API testing tools, the most famous one is probably Postman nowadays. Back in the day, I remember using something called SoapUI. In our specific case, we don't use Postman, we use Bruno, which is basically an open source counterpart, okay? Just to get a feeling, who here has ever heard or used any of these tools? Can I get a raise of hands? Okay, so most of you folks know what I'm talking about, and you probably know how it's a easy to use guided user interface for you to test APIs or even to design and develop APIs. And the thing that I found that was a major source of value for what we were trying to achieve is that I had a lot of developers that already had a bunch of collections of requests that simulated what the front end was supposed to do, because they use that to test themselves, especially from a back-end perspective, or even to communicate with other teams explaining, this is the flow that I expect from the API when it's implemented in the front end. Wouldn't it be cool if we could reuse all of those collections to create a probe? And so, an idea was born of, okay, instead of using the black box exporter or having people implement things out of scratch, why don't we create something that's based on Postman? Well, in our case, at the beginning it was Postman, then we migrated to Bruno. So basically, was something we called a Bruno probe. Essentially, it's a probe that allows you to run collections, the collections that you already have. So it will receive requests from a system like Honeycomb or Prometheus saying, hey, please probe that website, or please probe that service. And what it's going to do is, underneath the hood, run a collection that you've already fed it to simulate not just one request, but a sequence of requests that make sense and represent a full transaction, the same way you would if you would exercise the system through the UI. The funny part, and this may be useful for any of the folks here that find this interesting, is that this wasn't a complete original idea. Once I had this idea, I found that other folks already had the idea. So if you're using Postman, and a lot of people here probably are, there are already 2 open source projects that essentially implement this idea. And I will share the slides and the links later on. You can follow up on those if you want to play with these things and put something together that's similar to our approach. In our case, we had to develop a Bruno Pro, but it's basically a lightweight layer that essentially allows you to fire up a Docker container of something that knows how to receive HTTP requests, telling, hey, probe that place over there, and then underneath the hood has a number of collections that will be run, and then feed the results back to whoever called it. Okay. Maybe this was a bit theoretical, so let's look at an example of the process that I went through, but I'm going to use a way more simple, let's say, test subject for the effect. Okay? This is kind of a demo. I'm not going to do any live coding, but you're going to see the whole process I went through. We're going to use something which is a testing website, testing app from Mark Wintrigum, Automation in Testing .online. Thanks, Mark, for allowing me to use your test app as the subject for this demonstration. It's basically a bed and breakfast booking tool. Okay? So everyone here, I guess, can imagine the kinds of things that you can do. In our case, we're going to book a room into this bed and breakfast. And I implemented a UI test using Selenide and Selenium under the hood that actually does that. So we're going to go into the web application. Now I'm going to go into the calendar because I need to select a number of days where I want to book my room. I've already selected them. Now I'm going to fill out my details over there. And then I'm going to press book. And there you go. I have my booking. It's successful. Because I want my test to be self-contained, now I'm going to go into the administration console. I'm logging in, and I'm going to delete the booking I've just created. I'm looking for the booking finished that ends with Provenza in the name, and I just delete it. And this is the test that I have. And this is kind of like simulating a core use case of this specific web application, which is people can go in, they can search for rooms, they can book for specific dates, and then in the end, an administrator can cancel a reservation. Okay? What I did afterwards is that, okay, now that I ran this whole scenario with my UI automation, I'm going to check all of the requests that were happening in the background to my backend services or my backend API to capture all of the things that were happening from a backend perspective, because this is the thing that I want to exercise from a synthetic monitoring perspective. The thing that I do is that I start exporting all of these requests in curl format. Curl is just a tool that you use in a terminal to run a specific request. And Google Chrome DevTools actually allows you to do that. You can just export all of these requests in their curl format, and then you can run them in a terminal if you want. And they will be very much similar to the requests that came out of your browser to the backends. When you go to Postman, or in our case, I'm using Bruno, what I do afterwards is that I just import those curl requests so that I get them set up. Oh, this is really hard to read with all of the light, isn't it? Yeah, is it possible to shut the lights or something? No. No. All the buttons. Yeah, this is probably better. Is it better like that? Okay, cool. Sorry about that, folks. I hadn't realized that you were having troubles in reading. And so I import them directly in Bruno, and then you can see that you start having all of the requests there that kind of make sense. You're accessing the website, you're getting something called branding, and then information about a room, and then you post a booking with the information that I had. Here's the payload, my name, my last name, check-in and check-out dates. And you can simulate the requests within Bruno. It's the whole use case that you saw in the UI, but translated into the backend API requests. Afterwards, we can run this as a collection in Bruno or Postman. You've probably seen this kind of thing. One thing that I just want to point out here is that you can see how fast this is when in comparison to the UI test, right? The other UI test that you were observing probably took like 30 seconds to complete, whereas the backend requests are taking 3 seconds to complete. And will be important later on, and I will explain why. Okay, now I have a collection that I can run against the backend that simulates what's coming from the front end. Let's set up a probe that is able to run that under the hood. And this is the thing that I have. I have the probe as a running container in my machine for demonstration purposes, and I'm calling it, telling it, hey, please probe target AOT, automation and testing, and it already knows, okay, if I want to target that target, I'm going to run this specific collection. This is the multi-target pattern, exporter pattern. As I said, we don't really need to go into detail here, but things that are interesting, this is the language that all of the monitoring tools are going to understand using OpenTelemetry collectors. There's something called probe success here, it has a value of 1, which tells the system, yes, I was able to successfully probe the thing. And actually what I did is that I ran all of these different steps, which are all of the requests that form the complete use case. All of them got a 1, which is a successful status. And I can even do assertions on these things to make sure that I get the right payloads and whatnot. I also have duration in seconds, which gives me performance. So this whole thing took 3 seconds to run. And for each step, I also have how long it took to run. And this is that common language. I can just take this information and feed it into a dashboard. And this is one of the dashboards that we have set up in Honeycomb, just for you to get a feel of what I'm talking about. We are feeding this data there, and then the type of metrics that we focus in dashboards that we look at, it's essentially if the probes are being successful or if they fail, as you saw before. Also the probe performance, because we are collecting that data, and it's actually really useful. Even this example is a good example that happened to us, where all of a sudden the system started behaving way slower than it used to, and it was immediately apparent by the data that we were getting from the probes. But also something else which is really, really powerful is the fact that we have the probing or the testing data ending up in Honeycomb, which also collects the data coming from the backend, being errors or being all of the trace data of all of the things that are being called underneath, allows us to look at all of these things together in the same tool. And that's really, really important. This is something that happened to us. At one moment, when we were setting all of this up, we had a testing environment running our product, where we were using the 2 approaches in parallel. We had the UI automation tests running against it and producing production traffic throughout the day. And we also had the probes producing the same kind of traffic throughout the day as well, and we could compare both approaches. At one moment, during a working day, all of a sudden, all alarms started going off that testing environment was down, in the sense that both the probes and the UI tests were failing. Immediately, myself and a colleague of mine, we went into the probes dashboard, and we could see, okay, I can see that the time the probe takes to complete has skyrocketed, so something's up. I can see that there's a specific request that actually generates a PDF report, is taking way longer than it did before. It used to take 5 seconds, and now it's taking 30 seconds and timing out. And I can also already jump back into the backend data that's telling me the exact same thing. I just took 30 seconds to take care of a PDF generation, and I can look at the trace, oh, okay, there's a problem with an underlying library that's crashing with an out-of-memory error. And this was like in 5 to 10 minutes, we could go from a probe alert to understanding what exactly was the nature of the problem. At the same time, there were a few colleagues of us that were looking at the UI tests, and their experience was a bit different. They went to Jenkins, they saw that the UI automated tests were failing, they tried to understand more or less where it was failing throughout the user flow. They went into the source code. I think one of them was trying to simulate the same thing in their own machine so that they can look at the backend requests, so that they can get a trace ID to then go to Honeycomb and essentially come to the same conclusion as we did. And by the time we told them what was happening, they were still basically in this step. And I'm a big fan of observability. I'm a tester, I'm a quality engineer, but I'm also really interested in the observability world. And one of the things I always say is that hopping means friction within the observability world. If you have to hop between different contexts and different technologies to understand what's going on with your system in terms of the logs that you obtain, that is going to vastly increase and be a big hurdle for your capacity to troubleshoot problems in production. Sometimes we can't escape it, but when we are able to escape it, which we were able to with the probes approach, then it becomes really valuable. This is a quote from Charity Majors. She's one of the, one of the most well-known people within the observability world, and she's been talking about this idea that the new age of observability, Observability 2.0, is all about having one source of truth, which means having one data source for all of your data and several views. And in my quality engineering mind, that means having probing or testing data next to your production, your backend service data that allows you to correlate things in conjunction, which was exactly what we obtained here with this probing approach that I've just described. Okay. Another thing that I also want to cover, because before I wrap this up, with great power comes great responsibility. No, I'm not going to use this quote. What I want to say is, with great speed comes great flexibility. As you saw before, because I mentioned, we went from these UI tests that basically took 30 seconds to run in the example that I gave you, and we reduced that to 3 seconds. In our real live UI scenarios that we have and that we are running, it's more like they take 3 to 4 minutes to run, and we have reduced them to 10 to 12 seconds. That is a complete overhaul and a revolution of the things that we can do from a monitoring perspective, especially when it comes to the sophistication of alerts that we can put in place. Because when you have something that takes minutes to run, and in our case we were running it against a number of targets, meaning that you can only run this full automation set every 30 minutes or something like that to generate this traffic, when it fails, a human being should look at it, because you're not going to do a retry and wait I don't know how many more minutes before trying to realize if a problem is at hand. But if you reduce that time to something like 10 or 12 seconds, then you can have a higher frequency when you're monitoring, when you're probing the system. And so maybe you just wake up someone in the middle of the night if 2 out of 3 probes fail, instead of failing immediately. It gives you way more options when it comes to having better alerts, so that you don't exhaust the poor on-call fellows with false positives. And so that is a major source of value that we got from this approach. Okay, main benefits of the new approach, as I was saying. Having the probe and the backend data in one place is very good. It vastly reduced the time it takes to troubleshoot something. Faster probes allows us to have better frequency, as I've just explained, more sophisticated alerting. There's also the fact that we have a thinner automation layer. We don't have the front end anymore. We don't have the automated tests in there anymore. And it's actually more stable when you're doing these things at the API level. And finally, there's also something which is more socio-technical in nature, which is the team that actually owned the UI automation tests that were serving both the purpose of testing but also monitoring, was really appreciative that we lose the monitoring responsibility, because it was giving them a lot of constraints in the way that they could evolve the tests themselves. In the sense that maybe they wanted to add some stuff in or eliminate some stuff, but there were always limitations to the things that they may decide to do, because don't forget that these automation scripts are used for monitoring, so we need to maintain them in their current form, and they need to be as fast as possible in order for us to have a system that is that we can use. And they were really happy with the fact that we're using a different approach for monitoring, and we can, enhance our automation set for the purpose that it was built with. Thank you.
Yeah, that was a great talk. Thank you, Joao.
Thank you.
So we are open for questions.
Hello, thank you. It was amazing. I have a question. This kind of monitoring testing you're running, where do you usually run them? Is just for QA testing environments, or you also run them in production?
No, the idea is to run against production.
Against
yes,
production.
to generate the traffic against production, because our on-call team is only going to be alerted about stuff in production. And even measuring SLAs and all of that only makes sense within production, yes.
And I had another question.
Yes.
In my case, for instance, I don't have EUI testing. I just have a whole backend API testing, and we have a full coverage. So how we can integrate the work we already have, making all those API requests, and so for having the monitoring step, is it, well, I suppose it's possible.
Yeah, of course. I mean, if it's something kind of similar to what I was describing, in the sense that you already have these test sets that are basically exercising the APIs. I don't know exactly what you are using for that effect, but you could repurpose those to generate traffic in production and monitor for that using a Prometheus probe approach, if that's the kind of thing that makes sense for your company and in the context that you're in. Don't forget the things that I said at the beginning, which is, okay, what kind of business, what kind of traffic do we have? Does it make sense to do synthetic monitoring? Does it not make sense? Because it really depends on the case that you have.
Okay, thank you.
Yep. More questions? Aurelian.
Hey.
Hi.
So, of course, dividing by 10 the execution time is great, but what do you think about having the alignment or missing the alignment with the front end? Because in this solution, if front end will change the API calls, how can you guarantee that your monitoring check will still do the same thing at the front end?
Oh, so one thing that the teams that are now using this, they do is that there is a risk there, which is, okay, the UI has the advantage of, if the UI is working against the backend, automatically my automated tests are valid for using against production. Whereas if all of a sudden I change something in the UI and the way it interacts with the backend, maybe we don't remember that the probes exist and we need to change the probes as well. In order to counter that risk, what teams started doing is that they also have probes running in development environments. They're not running them every 30 minutes or every 10 minutes. They run it like twice a day or three times a day, so that they detect whenever they produce a breaking change in the APIs that they didn't accommodate into the probes, and that they need to do that rework of the probes, preparing for a new release version or something like that. Does this answer your question?
Yes, thank you.
Thank you. So we are in a tight schedule for the next session.
I'll be around. If you have questions, just approach me and I'll be happy to answer if I can. Okay? Thank you so much.
Are you the steward of the? Are you the steward of the? I didn't get that. Steward. Are you the steward or are you the helper? Helping for now. Yeah, it's him. No, sir. You were in all the seasons.
Sorry?
You were in all the seasons, in all the songs. You were in all the...
I was in?
Yeah. Yeah, because you are here right now, but
Yeah.
you were before in all this.
Yeah.
I was confused. So you're doing just the introduction.
Yes.
Yeah. Okay. I was confused.
Okay. I'll give the intro and give it to you. You'll take care of next
Yeah,
things.
sure.
Yeah. Awesome.
Thank you, sir.
So.
Thank you.
observability with Selenium and Grafana. Stage is all yours.
Thank you all. First of all, I really want to thank a lot of people came here from Greece. I have a lot of people in the front row. And particularly George Panos that did an excellent presentation, so I'm a little bit scared that mine will be like boring and dull. Hopefully not. So I will try to talk about observability in this talk. It's about beyond logs, how we can achieve observability when it comes to UI test automation. And we'll start a little bit with some theory about observability, but first thing first. Γεια σας. Γεια σας. I hear a lot of γεια σας. So, I'm Yannis. I'm a head of QA at Snappy. I'm based in Athens. I really love working with everything that touches product and engineering. I'm a Grafana champion. I'm also a Lambda test ambassador. I think we should tell that in the presentation. I love hiking and fishing. I'm not this guy. I wish I was, but it's just another photo of, I generated. It's a GIF, actually. So anyone, if you want to find me, I have my email also in the end. In the last slide, we'll talk about this. So the agenda of the talk, we'll talk about the observability theory. We will deep dive into Prometheus, Grafana, and how we can use the Grafana stack together with our Selenium stack. And we'll see some case studies when it comes to Selenium, how we can monitor Selenium Grid or even our automated test pipelines. We'll get some gathering and some learnings in the end, and anything you want to ask me, feel free, but not the guys from Greece. They already know about mostly everything. All right. So let's start with some theory. I don't like theory. We are engineers in this room, most of us. But we need to talk a little bit about that as well to cover the basics around observability, how we can use observability, what is observability, and why do we need observability when it comes to UI test automation. So systems are observable by the data they produce, we say here. So in turns, we help determine if our infrastructure is actually healthy and it's functioning normally. It's actually a process that making our system internal state more transparent to our teams. There is a big difference between observability and monitoring. Anyone? What is monitoring and one difference that you may think we have? Not from Greece. I don't accept answers from here. So monitoring focuses on collecting data, right? Observability is focusing on understanding, interpreting all this data, what's the problem in our system. We need to gain a deeper understanding in order to get the outcome of a healthy system, how we can actually fix the system or a performance issue that may arise in our system. So observability, it's more, let's say, proactive, more holistic approach to manage more complex systems, right? Have you seen this term in another case, anyone? Which one? This one? This is for observability. Anything like similar to this? You have seen that before? Accessibility, yeah. Kubernetes, K8 test. So this is O11 or OLY. It's a term that it's an abbreviation for observability that developers, they want to make sure they are very brief in the terms that they are using. That's why they have this term. So we can take why it's 11, because it's 11, exact 11 characters between O and Y. So you will see here, and that's why we refer to this term, which is a brief term. And as I said, accessibility is one another abbreviation. We have Kubernetes with 8 characters between K and S. So they want to be brief, and that's why we have this term. All right. So let's go a little bit deeper in the theory. You had coffee, right, everybody? All right. So this is a body. Think now our bodies, they are consisting of multiple layers, multiple systems inside. So there are different functions as well of each of these components that we have in the body. For example, we have the digestive system, so it helps digest food, or circularity system that pumps the blood throughout our whole body, let's say. All these systems are actually come together. This is the digestive. All these systems come together and we have actually the whole body, right? So it's a complex mechanism. And why I'm talking about this, we'll talk a little bit later on that. When something happens to our body, we need to go to a doctor, right? First, they need to take our vitals. So they take our blood pressure, the oxygen level, our temperature. So you see all these metrics. Now, there is a normal range when these metrics should fall. And if we observe something outside of these metrics, we need to make sure we notify what is wrong, in which component of our system, of our body, something is wrong, right? So after taking all the vitals into account, the doctor will make some questions to us, to the patients. They need to know more context about the problem. They need to find out where exactly is the problem. So they need to trace it. So you get my point on this. So the doctor may run some tests, and based on this information, let's say the doctor suspects something, that we have a mild bleeding somewhere in our digestive. They need to do more tests. So to figure out the source, we need to do some, we need to tag, for example, the red blood cells with tracers and visualize how these are actually travel throughout our body. So the doctor can understand from that, from the tracers, where exactly the problem is. So the doctor is alerted at some point and can understand, pick up a group of doctors and try to figure a solution for a healthy problem that the patient can have. So why I'm talking about this? Because we can apply all this process for observability in software systems, right? So it's the same principles, the same basics. When we are talking about software systems, we can talk about an application which is really complex. We need to understand what the problem is when we have a performance issue in the software system, and we need to get some context around it, right? And then we can come up with a plan, like the doctor, and try to resolve the issue or prevent the issue from happening in the future. So let's go back. So you see here, we have the complex body. Here it's a typical example of a software system running with the middleware. We have UI can be split on different components. We have the backend services. Some companies actually develop like hundreds of microservices running in the backend. Even hundreds of, okay, not hundreds, but a couple of databases you see here in the right. So you understand the information that flows from the UI layer to the backend, it's actually chaotic. So we need to have a way to trace if something goes wrong. Now, the first thing of observability, of the first pillar of observability, is the metrics. The metrics is what we said earlier, the vitals for our body. We need to take the vital signs, we need to collect metrics, and here you can see like a Grafana dashboard very nicely that visualizes all these metrics to the user. So the metrics are numerical data, like the blood pressure or the temperature. They provide clues about our health of our system and the performance of the software system. We need to take these vitals and make sure they are inside the range that we discussed earlier. So it's an approach that it's very similar and clear for the observability metrics that we're going to see today. We need to collect numerical data. Now the logs is the thing that is telling us what is happening, right? We know that something is wrong, and like the doctor talks to the patient, we have the logs. It's not very clear, but here it's a Grafana dashboard that shows the logs of our system. And we can refer to the logs to get more context about our system and get more information. And the last part is the traces. So we need to understand to trace where the problem is. So that's like the doctor examines our body and makes sure we have tracer in our bloods. Here are the traces. We have another component in Grafana which is called Grafana Tempo. It's very nice. You can pick up and find the root cause of your problem. Now, observability stack, I'm pretty sure you have seen a lot of this, right? Anyone used Dynatrace? Raise hand. Oh, you used Dynatrace? Really? That's cool. Grafana, anyone? Nice. Datadog, there are a lot. I mean, it depends on how your engineering teams are using them, but most of them are really a lot of tools in them, in the community that you can take benefit of. Of course, we are going to talk about Prometheus and Grafana in this talk. So Prometheus one-to-one. So we see here, this is the architecture of Prometheus. Who used Prometheus? PromQL? A lot of people. Nice. So Prometheus is using the central part is the Prometheus server, which is the hub, actually. It's the brain of the operations, let's say. We have Alert Manager, which is the component that pushes alerts and notify teams. It's like PagerDuty. You can use email hooks like Slack, Teams, whatever you are using as a messaging for you. We have the data visualization, of course. This is the part of Grafana querying our metrics and the data from Prometheus server through PromQL. And sometimes we use also Push Gateway. Who knows Push Gateway? You like it? You can live without it, right? So Push Gateway, it's for short-term jobs, right? It's not always good to use it, but if you have something that is running very fast and you want to query data or metrics out of it, and this is why in Selenium world we use Push Gateway. In this talk, we'll use a lot Push Gateway. Now, so what we do is we create our target application, whatever that is. We want to make sure we use Push Gateway to get the metrics or push metrics to the Push Gateway, then Prometheus to collect this from Push Gateway, and then we have Grafana and the nice visualization. This is just the flow that I'm describing today. And this is just an example, of the configuration file of Prometheus. You need to make sure if you are running through Docker Compose, always refer to the host Docker internal. I'm just, a painful point for me because if you use Docker, you need to understand that everything lives within the container. So you need to be very careful how do you set up all the target application to the stack. Now, why I'm talking about observability, I spent too much time with the main topic is Selenium, right? So you know Selenium Grid. This is our case study. What we want to do, it's a complex system, right? We have, in the new architecture, we have a lot of components. We have the queue, distributor, router, session map, event bus. There are, a bunch of them. And a lot of companies that don't use a third-party vendor, for the device farm. So they want to make sure they notify or they can use a way to trace things through the observability stack and how we are going to do it. So the case study is pretty similar as before. We have Selenium Grid, which is our application right now. What we want to do is we want to push metrics out to Push Gateway, and then Prometheus scraps the data from Push Gateway, and we collect through Grafana. And nicely, we can see how the Selenium Grid is performing all the time through Grafana. This is the main concept of what we are trying to see. Now, a little bit more details. What we can use. Of course, we are using the API of Selenium Grid behind to get these metrics. So one of these metrics can be the hub session count. It can be the max session, how many sessions are actually active in our hub. You see most of them are around hub, but you can configure your own exporter. I didn't talk about exporter much, but it's a basic concept to use when you are developing a Prometheus client. So what we want to do is to create an exporter that exports all these metrics to Prometheus through calling API calls to Selenium Grid, which is up and running. And we have the session queue size, or even maybe we can make sure if our grid is up and running. If it's down, we just notify our teams. The grid is down. You need to take some actions, prevent this from happening again in the future. Now, the Selenium exporter and most of the exporters in Prometheus, they are based in Go. It's Go libraries. It's the client libraries that you built in Go. Anyone developed in Go here in the room? Oh, nice. So, it's lightweight libraries. What they're supposed to do is just they query, as I said, the API, and then they can expose these metrics to our Prometheus instance. For that reason, I give an example here in our Docker Compose. We built an image of this exporter, which is the client library, and we can send a command with the URL of the Selenium Grid to make sure it can collect the data and the metrics from this Selenium Grid instance through specific ports. This is just an example, but what we have done internally, we wanted to build something custom that can query our Selenium Grid API, as you may know, through GraphQL, and through this, we take all the responses of the API and we send this as metrics to Prometheus. Now, here it's another example, some functions of the exporter. I'm just saying some here, like the new exporter or the describe. You will see here we just provide which metrics we want to collect from Selenium Grid, like total slots, how many sessions we have, or the count, or even the nodes that you have in your Selenium Grid, and you need to query them and just provide them as metrics, as we said earlier. So this is mainly the main functions of our exporter. Of course, you need to define the metrics, and these have been done here in the exported section. These are gates metrics, by the way. Do you know gates? What is the difference from counter? Anyone? Do you know gates, counters? They are typical metrics from Prometheus, by the way. It's like counter. Like we want a metric that we can easily increase or decrease, and this is the gates. And here we define some description around the metric. Here we define if the name is up, if our system is up and running, and you always need to define also the help. These are some attributes around the Prometheus metric. Then we have the collect. This is the function that we actually collect the metrics. It's called by Prometheus, at regular intervals, and it's actually provide the current data querying the GraphQL of the Selenium Grid. And what we do in the main function, let's say, of the Go exporter is just to register everything and have everything up and running. Right, so in a sense, the exporter, as we said, is our target application. We use Prometheus to collect through the exporter the metrics. We then use the alert manager very easily to go through the teams and alert when our Selenium Grid have any outages or you have any problems. Those is the main, let's say, concept of observability when it comes to Selenium Grid. And again, I'm repeating myself just to shake things up and make it very understandable. This is our grid. We have hub. We can have nodes. We can have a device farm. You can have your mobile devices, your desktop instances. Everything is here. And then you just start querying GraphQL API of Selenium Grid to push gateway, Prometheus, and alert manager. And in the end, your team is aware when something is wrong with your infrastructure. Here's another example of the alert manager. It's cool because with the YAML configuration of alert manager, you see here an expression like I can go and get an instance on my alert manager. I can use parameters, parameterize the description of the message that I want to provide to our engineering teams. For example, here the expression that alert manager is trying to match is that the app metric, it's equals to 0, which is a numerical value, or 0 or 1. And when it's 0, we make sure that the Selenium Grid is down, and then we need to trigger an alert to our teams. And this is the example of how to configure it for Slack. You will see the message from Alert Manager saying, Selenium Grid is down. You can define your channel here on the Slack configs, and here the API URL, which is the webhook URL for configuring the integration between your Slack and your Alert Manager. Cool. So we have Alert Manager, we have everything in place, so let's see some dashboards now, which is really cool. We need to make sure we get some information visualized. So here in Grafana, what we use PromQL. It's not very clear, but in the dashboards, we can go and use the data source. The data source is the Prometheus instance that we have installed. And from here, after we have push gateway collecting metrics and pushing to Prometheus, you can just use PromQL directly, or Grafana has a nice way. You don't even need to know PromQL to query your data. It's a nice way because they have all the needed configurations in the widgets how to query your Prometheus instance. And you will see a nice widget as well here. We're querying the app metric from Selenium Grid to see, to the team that the Selenium Grid is up and running. It will be red or down. You can configure whatever the visualization can be. It's really cool, though, because the team is aware all the time of if something is wrong with your grid infrastructure. Now, the last part of this talk, one case study is the Selenium Grid, which is a complex system, right? And we need to observe how grid is going on, if you have develop your own solution internally. Now, the last thing is end-to-end tests. Right? End-to-end tests are really slow. That's why we have all these talks about empowering the teams, have more parallel sessions, parallelism in devices. Of course, as you said, the testing pyramid that everybody is talking all these years, the end-to-end tests should be very limited set of tests when we are testing our application. Why? Because these tests are really complex. Not only on tracing issues, if something is wrong, but they are taking also a lot of execution time, a lot of resources, especially for mobile, right? You start mobile, you need to install an APK, you are waiting a few minutes, and this needs to be cast for every device. So you understand it's really complex, really time-consuming. How observability and monitoring can help us a little bit to speed up the process? As I said, here it's an example of just a modern web application. You have your web app. We don't see the microservices, but you see in the user journey a lot of things coming to the back and forth front end. We have core systems. We have a lot of databases. Anything can go wrong, we said, right? And in this typical journey, everything is slow to respond back to the engineers or the QA people. So we need to make sure we have this feedback very quickly at the time we get something, we get a failure from this. Now from that, in this typical case study that we have developed, by the way, we have done a workshop around this topic, which I'm particularly very proud in another conference, but we use Selenium, we can use Java, it doesn't matter, we can use whatever programming language you want. We have JUnit or TestNG, we want to just like in Selenium Grid, we use push gateway to push metrics from the tests, and then we have Prometheus scrapping this data, Grafana, and you know the story. I think we said that earlier, right? This is the main concept of the Grafana stack, but we use push gateway because they are short-lived jobs. This test execution suite can take like an hour or 2 hours. After that, it's killed, so that's why we use push gateway. We don't push things without push gateway to Prometheus directly. Now, another component, we talked about metrics, but I didn't talk about the Loki, which is a horizontally scalable solution from Grafana. I used it a lot, especially when you have Prometheus, Grafana, everything in place. It's nice to have your logs as well, right? We didn't talk about traces, but we focus more on the metrics and the logs. So Grafana log, it's inspired by Prometheus, by the way, but it differs from Prometheus. Prometheus is for metrics, Loki is for logs, and Tempo is for traces, right? So what we use in our solution, Selenium runs our tests in the agent, and the agent just create a connection to our Grafana instance, Grafana Loki instance, to push logs as well. And then from our dashboard, we can use logql, like PromQL, to just query our logs very nicely in Grafana. So with one solution, you have Grafana to rule them all. Even Tempo, have Loki, and you have also the solution for Prometheus. Now here you will see an example. I'm using some labels. It's nice to put labels as well in your logs all the time, and you can query your logs anytime. You can see your Selenium test logs. It's really easy, and visualize them through Grafana very nicely. I think I don't have much time. So in the final approach, we have the tests running through TestNG, for example. You know TestNG, it's an old, I'm an old guy, I'm 15 years, so TestNG is like way back. Then just the unit framework. We have our test scripts running in different browsers in our grid. We use push gateway to collect the data from our tests runtime. And what we do, we define listeners. So listeners are actually capturing all these metrics runtime. We define here the client for push gateway, where it runs, and then we make a connection to the gateway through the listener to just start pushing metrics at the time of the execution. So some useful information like labels, we can set up the job names, maybe the project you are running your tests, or maybe the metrics names. For us, it's how many tests are passing, how many they are failing, how many they are skipped. So it's just an example. Runtime, we can get test execution very fast in our Grafana instance. And we use gates as well as a metric, as we did with the Selenium Grid exporter. We use the labels. Each time, what we want to use is to increase the number of tests we are passing. We want to monitor how the tests are doing, right? Runtime. And this is the example of pushing this data. In the listeners, we have some functions to capture events from the tests. When you have a failure or a success case, you just make the connection, you just magically push everything to push gateway. And testing dashboards at last. In Grafana, you create some pie charts or another cool visualizations. Why I'm telling you this, it's just a nice story, because if you have a long execution suite, just go there and query them, runtime. You can have your alert manager. Whenever you get a failure, you don't need to wait a CI execution to just finish. You can do this runtime and get the right team, diagnose the problems at the time that the failure is actually occurring. Now, before closing, what we learned, observability must see left, right? This is the shift left mentality. Observability is part of the engineering culture. And nowadays, engineering teams, they all know about observability, how to use observability. And we saw some cool case studies when it comes to Selenium Grid, how to observe our internal infrastructure. Not everybody or any company is using a cloud infra. Maybe you have your own solution developed internally, so you need to observe how the solution is performing and get alerts on time, alert your teams to make sure you are dealing with problems on your infrastructure. Observe the end-to-end test suites in a historical manner. Get data, have Grafana in one place. Getting all these metrics to Grafana is super powerful. We saw about Loki as well, if you want the logs of your tests in the same place as well. We didn't cover the traces, but you can also use traces, especially Selenium Grid now, it supports OpenTelemetry. You can actually create a simple case study around the traces as well. In the end, you need to cultivate observability in your QA teams. This is, as more complexity comes to the web applications nowadays, more complex applications are coming, more complex our testing solutions may be, and you need to cultivate this observability as much as possible within your teams. I think that will be all. If you need to get in touch with me, you can scan the barcode. Thank you very much. You have questions? Oh, thank God. Right.
Guys,
We don't have questions. Thank you. No, I'm kidding.
Do you have any questions?
No, I'm not seeing anything, so everything
Someone
is
wants
fine.
to ask? Someone wants to ask? Okay.
So in fact, it's not a question, but just to say that we have something similar. But in our case, instead of, as we are running our tests on Jenkins, what we made is a Jenkins exporter that, in fact, Jenkins exporter, what we do is also generate these metrics from the test and collect them, so we don't need to use the push gateway for that particular case, because the content is going to be available on the Jenkins.
All right. So in your case, you said that you are using an exporter for Jenkins.
Yeah, and this Jenkins exporter, you want to look for it in Uyuning project / Jenkins exporter.
That's the GitHub account.
It's open source, so you
can. Oh, nice. Very good. Very cool. It's nice to see that you have a similar case study.
Anyone more?
Thank God it wasn't the question.
Anyone?
Thank you for your presentation. I was wondering if you have your tests containerized and you would have, for example, a sidecar, could you then scrape immediately without using the push gateway?
As the fellow person said, we need to build the exporter if you don't want to use the push gateway. So the exporter can live and run through the containers directly to Prometheus. So if you have exporter, you don't need push gateway.
We don't have an exporter. But, I mean, we have Prometheus scraping all of our application logs from the different containers. So I was thinking if the tests are containerized as well, whether that would work. But I don't know. That was just
maybe, but I think the key difference here, I don't know why you don't use, but Prometheus, the whole idea is how to scrap data from your application. So you either create an exporter, which is a Docker image, it's a Docker container. So maybe your tests can be an exporter themselves, like create a Docker container that works as an exporter. And then the Prometheus, gets, it's scraping the data from this Docker image directly. But push gateway in general, the pattern says you need to avoid it as much as possible because you cannot delete the data from push gateway, so the metrics lives there forever. Of course, like the tests, if you don't have a Docker container, as you said, you have test execution, which lives like a couple of hours. It's really reasonable to use this solution of push gateway. I mean, if you don't have this approach of exporter implemented, but it's a nice one.
Okay, thank you.
Thanks.
Okay, any more?
I didn't say anything. Oh my God. This is the question, right? The reference.
No. First, ευχαριστώ πολύ.
Παρακαλώ.
And why, or have you tried out Mimir? Because you have all the stack, and you're saying all the time Prometheus.
Yeah.
And we have a problem because we need Thanos to be just for the persistence of the data. And have you tried out Mimir?
No, but it's a good case to start it out. So you use the same stack?
But as we need the metrics for in long term, we have to. We needed Thanos, and then we changed to Mimir. Right. Because Thanos was not scaling so good.
But you are using it for test infrastructure?
Yeah, for everything.
Well.
We have the same structure for production and for testing, so we're just doing everything there.
Okay. I need to contact you.
That's a problem, actually.
I will contact you after the conference. No, why?
Όχι.
No, please, σας παρακαλώ.
Okay, any more?
Hi, thanks a lot for the presentation. How do you think about traces in end-to-end tests? Because we talk about metrics and logs, and it makes sense for end-to-end tests. But on traces, it's kind of hard for me to think about it because usually it will be useful to have traces in your application and then kind of correlate that with a trace from an end-to-end test. But I'm not sure how.
Yeah, it's a nice question. How do I envision? I mean, one particular case study is the OpenTelemetry of Selenium Grid. So you have tracing directly in Selenium Grid. But we're not talking about Selenium Grid in the traces. So Selenium Grid is instrumented. You know that already. So if you want to find what's happening on your grid, you can use the tracing there. But in the case of running end-to-end tests, what I was thinking is like try to collect the trace ID from your test that has to do with the application itself. I mean, it's not about the tests themselves, right? And then you just need to connect your test instance with a specific trace ID on your application, just to help debugging purposes, analyzing, your test execution and everything. So this is the only, I think, idea that you can enable tracing over there.
So it's kind of a precondition that you have tracing in your application to then implement it in your...
If you are supporting OpenTelemetry in your application, yes. Yeah. Cool.
Thanks.
Nice to have questions. I really love it. No, I'm kidding. Because one fellow in the beginning said to me, I'm going to give you a very, very difficult question. Oh my God.
So, any more questions? Many thanks.
The guy over here.
Please. Okay, I will do the question.
Shit.
No,
unavoidable.
Okay, it's not a question. It's mostly like a step forward. I don't know if you have already done it, but maybe it would be very interesting when you create the dashboards where you could combine metrics from tests and the application itself. So we have the tests that fail, and this could have, let's say, 3 or 4 microservices. So you can see which one actually failed or what were the logs during the time that the application failed. So I don't know if at some time you have considered to create dashboards that have both test and application metrics.
Yeah, that's a really good question. I mean, and Grafana has
It was not a question, actually, right?
It was a suggestion. Sorry. I was looking forward to that suggestion. But, so yeah, I think Grafana have a lot of, I'm not promoting Grafana, I mean any observability stack, right? But we use Grafana for this reason in this particular case study. But it has a way to have, I mean, this solution that Kostas is referring to is a good friend of mine. So he's referring to a solution you can have logs, traces together from the tests. Yeah, I think for debugging and visualizing close with the application, it's a cool solution. Maybe we can develop something together. And it's super powerful because you don't have to want disconnected Selenium tests or whatever tests you have in your pipeline. You need to connect them somehow with your traces in your application. And I think it's, Grafana as a visualization tool has every information. I mean, it's very flexible. And nowadays, it's more easy actually to build a dashboard. Back like 2-3 years ago, it was really difficult. But now it's super useful and super easy. So yeah, I think it's cool as a suggestion. Yeah.
Okay, guys. Many thanks.
Thank you. Thanks.